Your lecturer is Thad A. Polk. Dr. Polk is an Arthur F. Thurnau Professor in the Department of Psychology at the University of Michigan. He received an interdisciplinary PhD in Computer Science and Psychology from Carnegie Mellon University. Professor Polk's teaching on topics ranging from the human mind and brain to cognitive psychology has been recognized with numerous awards, including being named one of the Princeton Review's best 300 professors in the United States. He is also a frequent visiting scientist at the Max Planck Institute for Human Development in Berlin.
Human beings can live and thrive in an incredible variety of different environments. Millions of people live in Mecca, in Saudi Arabia, where the average high temperature is 110 degrees Fahrenheit. Others live hundreds of miles north of the Arctic Circle, where the temperature often reaches 40 below. People survive in the Atacama Desert in South America, where it virtually never rains, as well as in Meghalaya, India, which can get over 15 feet of rain in a single month. We live in modern high-rises with every conceivable convenience, and in the forests of New Guinea without any modern technology at all. We can live under the ocean, and we can even live in outer space. No other species on Earth can thrive in such a wide range of environments. Kangaroo rats do great in hot and dry areas, but they wouldn't be able to survive above the Arctic Circle. Conversely, polar bears thrive in the Arctic, but they wouldn't be able to adapt to life in the Sahara Desert. Even plants are adapted to specific soils and climates, and if you move them to a radically different environment, they'll typically die. So, how can human beings thrive in so many different and extreme environments while other species can't? It's not because we're the strongest species on the planet. We're obviously not. We don't have the warmest coat of fur, and we can't run the fastest. We can't survive the longest without water, or live off the widest variety of food. No, the reason we thrive in such a variety of environments is because we can learn. More than any other species on the planet, we can adapt and change our behavior to better fit the needs of our environment. We learn to build shelters from the heat and the cold. We learn to dig wells for water. We learn to speak, to read, and to write so that we can work together and learn from each other more effectively. We learn to use tools and technology that not only help us adapt, but that can also change the environment itself to make it a better fit to us. Learning is such a basic part of who we are as human beings that it's easy to overlook it and take it for granted. So try to imagine what it would be like if you suddenly lost the ability to learn, but all your other abilities remained intact. So you could still see and hear and smell and touch. You could still walk and talk. You could still think clearly and solve problems. You just couldn't learn new things. What would that be like? Well, first, think about what it would do to your social life. Do you think you'd be able to make new friends if you couldn't learn? Probably not. I mean, after all, you wouldn't be able to remember anything about the people you meet, including their name. In fact, you wouldn't remember meeting them at all. Now, obviously, that would put a real damper on your ability to develop new relationships. What about at work? What jobs would you be able to perform if you couldn't learn? Maybe you could work at an assembly line where you have to perform the same physical tasks every day. That might work for a while, although as soon as the plant started making something new, you'd need to learn a new set of tasks and you'd be out of luck. And obviously, any job that requires any kind of problem solving would presumably be off limits, because you wouldn't even be able to learn and remember the new problem that you need to solve. And likewise, it wouldn't make sense to go to school or take classes. After all, if you can't learn, what's the point? Although I have to say, I do know a few college students for whom learning doesn't seem to be their top priority. What about entertainment? You think you'd be able to enjoy a book or a movie if you couldn't learn? Probably not, because doing so requires you to store away information about the characters and events of the plot in your memory. And without the ability to learn, you couldn't do that. In fact, you wouldn't even remember that you have a learning deficit, because storing away that information also requires the ability to learn. Now, as bad as this situation sounds, it actually underestimates how much we depend on our ability to learn. In particular, we've been assuming that you lost the ability to learn later in life. What if you never had the ability to learn to begin with? You'd never learn to speak or understand spoken language, much less learn to read. Worse yet, you'd never learn basic motor skills like walking, standing, or sitting up. Even potty training requires learning, so I'm afraid you'd be out of luck there too. Essentially, you'd need someone to feed you, change you, and care for you for your entire life. So, learning is obviously absolutely crucial to our lives as human beings. Our ability to learn and adapt is undoubtedly one of our most important and powerful assets. And you could argue that our capacity to learn has never been more important than it is today. A few hundred years ago, most people could do just fine without too much formal education. Once you learn to farm or to work in a particular trade like a blacksmith or a bootmaker, you'd typically perform that same kind of work for most of your life. And so new learning wasn't quite as crucial. But the situation is radically different today. For example, the Bureau of Labor Statistics reported that people born between 1957 and 1964 held an average of about 12 different jobs before the age of 50. And more than half of those jobs were held after the age of 25. Obviously, today's workforce requires people to learn new skills all the time. And it's not just our jobs that require people in modern society to learn. Scientific advances have radically changed our environment and require us to constantly learn about new technologies. I mean, in my lifetime alone, we've gone from 8 tracks to cassette tapes to compact discs to iPods to music streaming. We've gone from rotary dial phones to push-button phones to cellular phones to smartphones with a bewildering array of functions and apps. We've gone through something like 25 different versions of the Windows operating system and a similar number of versions of the Mac OS. We now have quantum computers, gene therapy, 3D printing, nanotechnology, and a host of other technologies that we never could have imagined 50 years ago. And if anything, it looks like the pace of change is accelerating. So the importance of being able to learn efficiently and effectively is only going to grow. And that means that investigating how we learn is one of the most important scientific endeavors around. After all, if we could figure out how people learn, then we might be able to help them learn more effectively. We might be able to offer teachers advice on teaching methods that promote the most learning. We might be able to offer students advice on how to study in a way that will optimize long-term learning and retention. And we might be able to help everyone optimize their own learning at home, at work, or wherever they may be. And there's some very good news on that front. Psychologists and neuroscientists have made a lot of progress in understanding how we learn and how we can optimize our learning. In the last 15 years alone, new discoveries have been made about how learning works that have important implications for real-world learning in the classroom, at work, at home, and at play. Unfortunately, most people don't know about many of these discoveries. And that includes most teachers and students. And as a result, Most people are trying to learn using strategies that are already known to be less effective than they could be. But it doesn't have to be that way. There's no reason people can't apply the recent discoveries about learning in order to learn more effectively themselves. They just need to be educated about learning itself. Well, that's the goal of this course. Specifically, I want to help you understand how the truly amazing learning mechanisms in your own brain actually work, so that you can get the most out of them in whatever kind of learning you're doing in your own life. And to accomplish that goal, we're going to really dive into the psychological mechanisms that our minds use to learn in every walk of life. We'll discuss the mechanisms we use to learn in the classroom, in the music studio, and on the athletic field. We'll talk about patients who have severe learning impairments and what they tell us about the mechanisms underlying our own learning. We'll discuss how factors like aging, emotion, and sleep can affect learning, and the lessons that we can draw. We'll also dive into the neuroscience of learning, which is one of the most exciting and rapidly expanding areas in the field. We'll learn about some of the most important scientific experiments in species ranging from humans to sea snails, and discover what they've taught us about the neural mechanisms that allow us to learn, and how the brain itself changes whenever we learn something new. But we won't stop there. We'll also repeatedly identify important practical implications that we can put to use in our daily lives. We'll learn about study strategies that have been scientifically demonstrated to improve learning, and about other popular strategies that you actually might be better off avoiding. We'll discuss experiments examining how we should practice if we want to learn a new skill, like playing a sport or a musical instrument. We'll also discover situations like drug addiction in which our natural learning mechanisms can turn against us and lead us to learn behaviors that are actually more harmful than helpful. So buckle up and let's dive in. Let's start by discussing what we mean by learning. Well, one fairly intuitive definition says that learning is changing your behavior in response to previous experience. And that's not a bad definition, but there are a couple of important points to keep in mind that might lead us to refine it a little bit. First of all, I think we can agree that there are situations in which you learn something, but there's no opportunity to show it in your behavior. For example, suppose you read a book and you learn some interesting fact about Berlin, like that a former airport there has been turned into a park. You may well have learned that fact and stored it away in your memory, but it's quite possible that it will never influence your subsequent behavior unless you happen to visit Berlin or have a conversation about its former airport. And of course, the same is true for countless other obscure facts that you learn. Not everything you know is reflected in a change in behavior, but that doesn't mean you didn't learn it. So, we might want to revise our definition a little and say that learning is acquiring knowledge from experience. Now, that new knowledge could affect your behavior. For example, if somebody asks you if you knew that a former airport in Berlin had been turned into a park, then your answer would be different after learning that fact. But learning doesn't have to always be reflected in your behavior. Now, there's still at least one problem with our new definition, though. When people think of knowledge, they typically think of information that is consciously available and verbalizable, like the fact that 2 + 2 is 4 and that birds have wings. Now, we obviously do learn that kind of information, but as we'll see in this course, we also learn a lot of behavioral responses that are not consciously available. For example, if we sit in a room where a fan is blowing, we typically get habituated to the sound of the fan, and we learn to ignore it. That kind of learning has been studied extensively in lower organisms, and although you could call it a kind of knowledge, doing so seems a little strange. So let's define learning as acquiring knowledge or behavioral responses from experience. And the from experience part is also crucial. Learning might come from studying or from being taught or just from living life, but it has to come from experience. Behavioral responses that are genetically programmed, like instincts and reflexes, don't count as being learned. Okay, so if learning is acquiring knowledge or behavioral responses from experience, then what is memory? And how does memory relate to learning? Well, psychologists typically consider memory to be the result or product of learning. So learning is the process of acquiring the knowledge or behavioral responses, while memory is the record of that learning that's stored away in your mind. As we'll see, learning involves making physical changes in the brain that allow information to be retrieved later on. And those changes constitute the physical basis of memory. All right, now that we've established what we mean by learning and the crucial role that it plays in human behavior, I'd like to spend the rest of this lecture introducing the scientific study of learning and some of the major themes that we'll address in this course. We want to go beyond hypotheticals and plausible ideas and talk about rigorous scientific studies that have taught us about how learning actually works. Well, for most of human history, the study of learning was restricted to philosophy. And even after the power of the scientific method became clear in fields like chemistry and physics, it still wasn't applied to study the human mind for quite some time. In fact, up until the late 19th century, most scientists and philosophers probably didn't think that learning could be studied scientifically. Mental processes like learning and memory were seen as fundamentally different than the natural phenomena of chemistry and physics. But that all changed in 1885 when Hermann Ebbinghaus published his famous book Über das Gedächtnis, which means about memory in English. Like all psychologists at the time, Ebbinghaus was trained as a philosopher. But inspired by scientific studies of human perception that had recently been published, Ebbinghaus decided to try applying scientific methods to study human learning and memory. And his work ultimately revolutionized the field and helped establish psychology as a legitimate scientific field in its own right. Ebbinghaus used only a single human participant in his experiments, himself. And he wanted to study learning in a way that wasn't contaminated too much by what he already knew. So he decided to try to learn lists of meaningless syllables. What he did was to study a list until he could repeat it back twice in a row without any errors. Ebbinghaus plotted his performance as a function of the delay and produced what are now called forgetting curves. Now, as you might imagine, his performance got worse with longer delays. But the drop-off wasn't continuous. In fact, he found that most of the forgetting happened during the first hour or two. Performance after a day wasn't all that much worse than performance after an hour. And performance after 2 days wasn't much worse than performance after 1 day. Ebbinghaus also studied how much he learned as a function of each repetition. And like the forgetting curve, he found that the first repetition led to the most learning, the second repetition to a little less, and so on. And Ebbinghaus's findings have been confirmed in countless experiments since then. But by far his biggest contribution was to demonstrate that human learning and memory could be studied scientifically in a way that other scientists could replicate and extend. And the repercussions of that contribution are still being felt to this day. And over the course of these 24 lectures, we're going to explore those repercussions in real depth. In particular, we'll repeatedly see how the scientific study of learning has made major advances in at least 3 major directions. First, it has dramatically improved our ability to help people learn more effectively, whether in the classroom or in real life. Second, it has led to much better theories of the cognitive mechanisms involved in learning. And third, it's beginning to shed light on the neural mechanisms that underlie learning. Let's spend a little time talking about each. First, consider how the study of learning is helping people to learn more effectively. I recently served on a committee at the University of Michigan called Transforming Learning for the Third Century. The third century in the name refers to the fact that the University of Michigan has been around for over 200 years, and it's therefore entering its third century of higher education. But over the course of those 200 years, relatively little has changed about how we teach our students or how we ask them to learn. For example, in a typical college class, the professor gives a lecture a few times a week while the students take notes. The students are also assigned homework like reading books or writing papers or solving problem sets. Courses typically focus on a single topic for a few class periods, and then they move on to another topic in a hopefully logical progression. And there's also likely to be a midterm and final exam that tries to assess how much the students have learned. And that approach to teaching and learning really hadn't changed that much since the University of Michigan was founded over 200 years ago. Our committee was tasked with funding projects that would begin to transform learning for the third century of higher education at Michigan. But how can we transform learning and make it more effective? Is there really anything we can do to change how much we learn? Well, I'm happy to report that the answer is definitely yes. Learning scientists have recently discovered that there's a lot we can do to make our learning more effective, not only in the classroom, but also in our daily lives. For example, in Lecture 7 of this course, we'll discuss research demonstrating that although tests are typically used to assess learning, taking a test is actually one of the very best ways to help you learn. So rather than rereading a book or highlighting important points, you'll actually learn and remember more information if you spend your time testing yourself on what you've already read. We'll also learn about ways to optimize your learning of skills. For example, when most people practice a motor skill, like tennis or golf, they tend to practice one part of the skill at a time. Maybe they hit a bunch of forehands in a row before switching to backhands. Or maybe they hit a bunch of drivers before practicing their wedges. But did you know that you'll actually get better faster if you mix up forehands and backhands, or drivers and wedges? That's called interleaved practice, and we'll learn all about it in Lecture 13. We'll also learn about some of the factors that can have the most dramatic influence on how effectively we learn. For example, you probably recognize that getting a good night's sleep can help you learn more effectively the next day. But did you know that a good night's sleep after learning has also been shown to help you consolidate what you learned and remember it better? Well, these are just a few of many examples demonstrating how advances in learning science are helping people learn more effectively. And that's going to be a major theme of this course. Another theme will be the significant advances that we've made in understanding the cognitive mechanisms underlying learning. Now, many people think of learning as a single unitary process, but nothing could be further from the truth. In the past few decades, cognitive psychologists have discovered that human beings are equipped with a variety of very different mechanisms that are tailored for learning different kinds of information. For example, it turns out that storing and retaining information for short periods of time depends on fundamentally different mechanisms than storing and retaining information for long periods of time. Even the kind of information that we retain over those time periods is quite different. Suppose you read a word problem in a math book, and then you take out a piece of paper and write down the problem so that you can work on it. Well, when you want to store words for a brief period of time like that, it turns out that you tend to store the sounds of the words, not what they look like and not what they mean. Conversely, If you're reading a book and a day or two later you're telling a friend about it, you're not going to remember the exact words you read, much less their sounds. Instead, you'll tend to remember what the book was about, that is, the gist. So short-term working memory is very different from long-term memory. In fact, psychologists have discovered that we even use different mechanisms for storing different kinds of information within working memory and within long-term memory. For example, short-term memory for pictures involves completely different mechanisms than short-term memory for words. And learning a long-term motor skill like playing an instrument, that depends on different mechanisms than those involved in long-term learning of facts and knowledge. And this course will explore all of these different mechanisms involved in learning and in memory. We'll learn about how we learn conscious, explicit knowledge, like facts about U.S. history or English literature. We'll also learn about all the amazing unconscious, implicit learning mechanisms that we use to learn all the skills and habits that we exploit every day. We'll learn about long-term memory and working memory, about verbal learning and visuospatial learning. As we'll see, our brains are equipped with an amazing assortment of very powerful learning mechanisms, and I look forward to exploring them together. A third theme that we'll explore in this course is the way that recent advances in neuroscience are beginning to illuminate what's happening in our brains when we learn. For example, you might wonder if there are any physical changes in our brain when we learn a new piece of information. And it turns out that there are. We'll discuss a large body of work in simple organisms like sea snails that have actually managed to isolate the exact neural circuits involved in specific behaviors and to observe the changes in those circuits when the organism learns to change that behavior. It turns out that one of the fundamental biological mechanisms underlying learning is changing the strength of connections between individual brain cells. As amazing as it sounds, our extraordinary ability to learn depends largely on making millions of very small changes in the strength of brain connections. We'll also explore recent advances in brain imaging that have made it possible to watch learning happen in the human brain. Specifically, scientists can now see which parts of the brain are active when human beings perform different learning tasks. And these techniques have made it possible to test whether the psychological theories that have been developed can be mapped onto the brain. And as we'll see, different types of learning that have been hypothesized to depend on different psychological mechanisms have been found to depend on different parts of the brain. We'll also spend time talking about the effects of brain damage and what those effects can teach us about learning in the normal brain. Brain damage sometimes impairs one kind of learning, but not another. And those kinds of dissociations have helped scientists to carve learning at its joints, as it were, by illustrating what the different types of learning are and how they should be divided. In fact, the study of brain damage, and in particular the study of amnesia, has taught us so much about the organization of learning in the brain that we're going to devote our next lecture entirely to the topic. We'll discover that although amnesia produces dramatic impairments in the ability to learn conscious, explicit information, it typically leaves unconscious learning completely intact. And that fact has profoundly influenced our understanding of how learning works in a normal human brain. Well, I hope this initial lecture has whetted your appetite to learn more about the learning brain. We've now established a foundation on which we can build. We've discussed what learning is and why it's so crucial to us as human beings. And we've also learned a little bit about how the scientific study of learning got started, as well as some of the key themes that we'll address in the course. So, with that foundation in place, I hope you'll join me for the rest of the course as we continue to explore the fascinating world of the learning brain and hopefully help you begin to optimize your own learning.